Hi dear students. After the break now I'm ready to continue. The chapter of this week is on dimensioning. Well, almost finished the first part of the chapter. It is about dimensioning format. Well, you remember under the title dimensioning is the title of the chapter, Well, there are lots of rules to obey to satisfy. More than 20. Remember, first part of the lecture, I added 6 more quotients and, had in the list the extended part as well, 20 or maybe a little bit more in number rules. Okay, and talking about the dimensioning format, I underline the difference between the rules of ISO and rules of ANSI. And also, one more time talk about dimension line, extension line. Okay, and as the complementary new part in the chapter, talk about tolerance definition. I said, even in today's technology, it is impossible to set the size of any feature as exactly equal to a certain specific number. Impossible. So, for each dimension, there should be an allowance. Well, the operators, technicians are to be allowed in setting the size of a feature while applying the necessary or proper shaping process, cutting, hammering, casting, finishing. Okay, any process. Applying the process, the technicians should know that for the size of the feature there is an upper limit, a lower limit, and if the size of the feature can be set in the range bounded by this limiting values, then the feature will be accepted as sufficiently correct in size. The difference between upper limit and the lower limit of the size of a feature is called tolerance. I said, one more thing. If the feature is the one, it is going to be fit into or onto another feature of the object, another object, and both of the objects made of solid material, no doubt. Okay, then such a feature is called functional feature. Okay, the feature, it is to be mated into or onto another feature in the assembly, structure of the assembly, object is an assembly. It is called functional feature, and its dimension is called functional dimension. In this example, one more time indicate which dimension is functional, this one. Well, in the format of today, showing the dimensions of functional features, we write the nominal value. You know what is nominal value? It is the determinate size of the feature by whom? By the designer, of course. After solving the design equations, most of the cases, designer round the value, calculated value, obeying to a certain rule and using a certain logic, and the rounded value is written as the size of the feature, where on the technical drawing. Such a rounded value is called nominal value. It is just another point of view, say order of magnitude. It does not mean that it is exact. Well, if it is functional dimension, then next to the nominal value, here in this example 23 is the nominal value, a code is written in today's format. It is called a tolerance grade. Well, it is in the format of the International Tolerance Grade System. Yes, there is such a system, and this lecture I'm going to explain what it is. Well, code is written letter and with a number. If the feature is an empty feature, empty space, okay, in the jargon of technicians, an empty space is mentioned or called feminine feature. Okay, we write the code using capital letter. In this example, capital letter is H. Okay, using the letters of alphabet, we write a capital letter and then a number. In this example, the grade number is 7. Showing the dimensions of muscular features, solid features, not empty space but solid extensions. In the jargon of technicians, it is called or it is mentioned muscular feature. In Turkish industry, our technicians sexually say erkek dişi kısım. Okay, this is an empty space, feminine feature, dişi kısım. Okay, this one is an solid extension, this feature. It is a muscular feature, erkek kısım. Okay. If the size of the solid extended part is functional, then writing the tolerance code for muscular features, we use, in IT tolerance grade system, we use lowercase letters. Not capital H, but we use lowercase h. For instance, H7. This info is important, especially to consider not only showing the tolerance grades on technical drawings, but also making the recommended selection on the recommended tolerance grades. I'm going to make this sentence clear enough in few minutes. Okay. Well, to be able to make more understandable saying feminine muscular features and those saying functional features, let me give an example. Okay. In inventory environment, I have a sub-assembly. This gray colored component and this cyan colored component, blue component. And, well, another one, it is in the color of gold. It is a cylinder, piece of cylinder. Okay. Now here I'm going to, using the tools assembly environment, in inventor assembly environment, using the tool of inventor, I'm going to animate it. Follow. This blue part is to display between these two limiting positions, how? As being mated into this channel. The edge of the blue part, you see, is to reciprocate within the channel of the gray colored one. Yes, there is a mating between this and that, fitting. Well, depending on the demand of customer or knowing the function of the object, okay, for this mating fitting, by the designer, the clearance value is determined. If, of course, this is a mechanism to do a certain useful work, imagine that this is the ram of a crankshaper. While it is going ahead, well, imagine there is a tool post here and there is a tool, cutting tool. That cutting tool is to cut the material, is to cut the workpiece. Okay? Well, so to be able to use the energy provided by the engine, okay, for such a cutting process, the friction forces should be in minimum order to their effects. Well, if we have a very tight fit between this channel and the edge of this blue part, of course, because of the tightness, friction forces between the components at their mating surfaces will be very great, and measure of the energy provided to this part of the mechanism will be dissipated by friction forces, converted to thermal energy, and thermal energy will be transferred to the outside. To be able to make the efficiency of this mechanism higher, well, there must be a clearance between the channel and the edge of the blue part. Thanks to the existence of clearance, and well, furtherly to decrease the effect of friction, the contact surfaces may be oiled, may be lubricated, can have the friction forces at minimum level. So, well, depending on the case, if it were the case, for instance, these two components ought to be positioned with respect to each other fixedly. So, inserted into the channel with an interference and tightly have the connection. Then, well, the clearance, instead of having a clearance, we would have an interference between the components. So, depending on the demands of the customer or the function of the, considering the function of the assembly at the mating, via the decision of the designer, well, select the upper and lower limits of the features. Here in this example, the width of the channel and the thickness of the edge of blue part are functional features. You see, the edge of blue part is to find its place within the channel. So, edge of blue part is functional feature, and the channel of this gray part is functional feature. And the thickness of blue part, functional dimension, width of the channel is functional dimension. Okay. Can similar things for this mating. You see in this example, this cylinder is to find its place within this hole. Hole of this blue part is functional feature, and in the assembly this piece of cylinder is a functional feature. And the dimensions, which dimensions? Diameter of the hole of this part and the diameter of this golden component are functional dimensions. Okay. And then, well, after almost saying that finish the part, it is about dimensioning format, dimensioning rules. Then yes, now focus the attention to this classification. Well, not bringing this say figure, but delivering the necessary sentences already talk about functional dimension, non-functional dimension. But this item still weighting, reference dimension. I'm going to talk about reference dimensions later during the CAT application next week, not this week. Already talked about what is functional dimension, what is non-functional dimension, and already said that if it is a non-functional dimension, we just show the nominal value of the feature, not the tolerance grade. To be able to find the upper lower limits for non-functional dimensions, well, the necessary thing to do is that refer to the title block of the engineering drawing sheet. Okay, over there find the box entitled with this phrase general tolerance, and then gather the tolerance class letters. Well, see the example here. For instance, for 20, for 60, for 74, how the upper lower limits can be determined. The first thing to do is that refer to the title block and over there find the box. One of the boxes is to be entitled with this phrase, general tolerance. And over there will be the code of the standard, the document published by Standardization Association to refer for finding two valuable letters. ISO standards, in the publication its code is 2768. Well, keeps the necessary tables, these are in short called tolerance tables, to refer, well, to determine upper lower limits of the dimensions, for the dimensions. For non-functional dimensions, well, from such a node, well, the valuable part to gather is this letter and the other letter. The first letter is lowercase, second letter is capital. In MEC 113 and in CVE 101, the meaning of the first letter and the associated things are studied, are covered in the content and studied. The second letter is subjected in the content of MEC 114. The first letter is the tolerance class letter for non-functional dimensions. The second letter is the tolerance class letter for determining the geometrical tolerances of non-functional features. Size tolerance, geometrical tolerance. What is geometrical tolerance? What is the thing to do associatively with this capital letter? These are all answered, studied in MEC 114. You know, it is a math course for mechanical engineering students, complementary elective course for the other students. Okay. This record, or latest the next video record, I'm going to talk about how the upper lower limits for non-functional dimensions can be determined starting from here. Letter C. Okay, then how about the rest? Answer this question. For functional dimensions, yes, in this example there are two functional dimensions. One of them is this one, the other one is that one. You see, since this is a solid extension, the tolerance grade has been written by using or with a lowercase letter, G6 in this example. This is a feminine feature, empty space, feminine feature, sexually speaking. Technicians like to use feminine, masculine, these words. Okay, talking about empty space or solid extension. This is an empty space, so according to the agreement, common agreement, in accordance with ISO IT tolerance grade system, we show the individually determined tolerance grade, okay, using capital letters. Okay. As I said, in this classification, the third item still a question to its meaning. Later, during the CAT application, I'm going to clarify its meaning, as I said. Linear dimensions are classified into in other logic into two types: size dimensions, location dimensions. Example, if the dimension is thickness, diameter, okay, length, width, height, these are size dimensions. But if the dimension is to locate, to show the location of a feature with respect to a certain reference, it is called location dimension. Example, 21 is to locate, to show the location of the contour borehole. This annotation to say, you know, that there is a contour borehole over there. This dimension and that one, 15 and 21, these are to locate the axis of the hole. With respect to where? 21 is with respect to the most right surface, and 15 is with respect to the backside surface of this solid extension. These are location dimensions. But here, diameter 10. 10 is size dimension. Okay? 20 is the thickness, yes, of this extension. From this point of view, it is size dimension. But in other point of view, 20 is also a location dimension because it shows the location of the top side surface of this extension with respect to its bottom side surface. I think this is clear enough. Okay, one of the questions, say before the break, first meeting of this week, couldn't find time to talk about some other questions. One of them now saying, by the way, indicate in the list and then talk about it, explain. One of them is the common agreement. Okay, both of the widely obeyed standardization associations, one of them ISO, the other one American Association, say the same thing. All the nodes, technical nodes, including the nodes at the title block, should be written horizontally. So readable horizontally. Okay, it is a rule. Okay, and this is also important. It says that place a longer dimension line outside a shorter one. In other words, this is to say that show the shorter distances first and then longer distances later using another dimensioning line. Why? Example. For instance, here you see this shorter dimension, let's say 20 is the size of this feature, okay, has been shown not first but secondly. Although this is a longer distance, it has been shown precedingly. For instance, here it is 50, and extension lines are used to bound the distance, okay, to extend the size of feature. In other point of view, just for bounding the region. Here the extension line, this extension line is not the extension line for this dimension. It is the extension line for that one. Although it is so, since this extension line is crossing the dimension line of this dimension, a reader by mistake may consider this dimension as if it were the size from here to there. By mistake, considering this extension as if it were the extension line for this dimension. There is such a risk. So, to be able to prevent such possible misconsiderations or misreadings, the rule is valid and to be obeyed. It says that show the smaller distances first and then the longer one. If it is obeyed, see this, say, good practice. Smaller distance has been shown, greater distance later. So there will be no intersection along a dimensioning line. Avoid having intersections along dimensioning lines. Okay, dimension lines shouldn't intersect each other. Extension line should not intersect a dimension line. It is a rule. This is having such an intersection along dimensioning lines is really a poor practice. Okay? Yes. And the other one more time I highlighted, you know, talking about the distance to have between the projection and the dimensioning line, first coming dimensioning and successive dimensioning lines. I have already informed you saying that 10 millimeters is the minimum distance to have between the view of the object and the first coming dimensioning line. But here, one more time underline. Well, measure 10 millimeters not relative to the feature. For instance, this dimension, let's say 10 millimeters is the dimension, is the size of this feature. If 10 millimeters is the space value between the projection and the dimensioning line, is measured relative to here, relative to the feature, it is going to be wrong. Although this is the first dimensioning row, this is the first dimensioning row, this is the first dimensioning row, you see, instead of having them at the same level, we have them at different levels. This is wrong. Well, to be able to have the first dimensioning rows at the same level, yes, it is a format requirement. Well, correctly interpret that rule. It says, it is to say, measure 10 millimeters not relative to the feature of that dimension, relative to the most out boundary of the projection. In this example, most out boundary of this projection is this boundary. So measure 10 millimeters relative to that boundary. This is 10. For this dimension, measure the distance not with respect to feature, but with respect to the projection of the most out feature. So, well, if you measure 10 millimeters from the most out boundary, then the dimensioning lines will be at the same level. It is in the dimensioning format, the correct case. Okay. If the dimension is not a linear dimension but an angle, as it is illustrated here, well, about the corner of the opening, okay, draw a circle arc in hand drafting with the necessary termination symbols and then write the dimension. Both of the associations say the same thing using degree. Okay? Yes. And then now this slide is about the format requirement. Imagine that we have an object to its view here, and that's the dimension. Well, if it is a functional dimension, yes, need to show the dimension not via showing nominal value, but also individually selected tolerance grade. It is the format of today. Tolerance grade, nominal size or basic size. Nominal size. This code, well, later I'm going to explain how, corresponds to upper lower limits. This is the upper limit and this is the lower limit. And what are those? These are the deviations. Okay, now new definition. Upper limit minus nominal value, and V is nominal value. Okay, this difference is known as upper deviation. UD, I'm going to use UD to say upper deviation. Okay, and the difference between nominal value and the lower limit is called lower deviation. Lower deviation. Deviation. Okay. Deviations may be positive, may be negative, or one of them may be positive, the other negative. In this example, F7 corresponds to this deviation values. Negative, both of them negative. You know, in mathematics, smaller negative number is greater. Okay, so this is upper deviation, this is lower deviation. Okay, upper limit is equal to nominal value plus upper deviation. Lower limit, LL, lower limit, is equal to nominal value plus, yes, say plus lower deviation. If deviation is negative, then this expression going to be inherently subtraction. If lower deviation is negative, then it is going to be automatically subtraction. Okay? Always say positive, plus. Well, the value of the deviation will make it summation or subtraction. Okay. If in the company all the readers, sure that are educated readers, then well, showing the functional dimensions, this is sufficient. Just show the tolerance grade. Because educated technician can make the necessary things to find the upper lower limit. But in your company, if it is your job that well, some of the technicians are not so good on determining the upper lower limits, okay, they may make mistake or completely vanish. Then for the convenience of technicians, okay, this is better. After showing the functional dimension in the format of today, in the parentheses, well, write the determinate upper and lower limits. These values are determinate referring to tolerance tables. But if you're using the CAD environment today, AutoCAD or Inventor, not AutoCAD but Inventor, in Inventor it is possible making a click to have not only tolerance grade but also in the parentheses these are written by the software, the limiting values as well. In AutoCAD, deviations can be shown, okay, making a certain click in the structure of the software at this stage. I'm going to demonstrate how during the class time. It is gonna be about the CAD application. Okay. Beforehand, saying beforehand, not so sure, but I mean 20-30 years ago and also more years ago, well, this format was used. In the old format, for functional dimensions, writing the nominal value, deviations written. Okay, in this example, one of them positive, the other one negative. Well, the deviations, written deviations, are not codes. These are deviations, so the unit of this number is millimeter. If the dimension is on the first quadrant projection, you know, millimeter. Civil engineering, it is mentioned at the legend or title block. It may be centimeter. Okay. The unit of measurement in this format, old format, it is used for the deviations, in writing the deviations, the same. So, well, these numbers can be directly processed. For instance, here, upper limit in this example, upper limit is equal to this plus that, 32.1 millimeter. Lower limit is equal to 32 minus 0.2. It makes 31.8, I think, millimeters. So tolerance is equal to upper limit minus lower limit. In this example, it is equal to 0.3 millimeters. Yes. If the deviations are the same, are equal, then of course, to save space and time, yes, it is allowable, say plus minus, write the commonly used deviation value. Okay, well, one deviation, if it is 0, then write it 0. Okay. Or if your technician's not so good on making such a shopkeeper calculation, then calculate the values and then write upper lower limits, okay, in the old fashioned format. Okay. Yes. Here, another classification, we say datum dimensioning, chain dimensioning. Well, chain dimensioning, see an example, especially the location dimensions for the features are shown like a chain along the same row, dimensioning row. In this example, the location dimension for this drill, for the axis of drill, has been shown relative to here, this reference. And then the location of the second hole has been shown with respect to the center of the first hole. Yes, in chain. And the location of the third hole, has been shown with respect to the second. For each in this example, the deviations correspondingly, the tolerance, are the same, 0.2, 0.2. But relative to a common reference, for instance, this edge of the object, then, well, when the holes are drilled using these dimensions with respect to each other, measuring the coordinates, then, well, for the second hole, relative to such a common reference, the deviation may be too much. Well, tolerance for the location of this one, you know, is 0.4, 0.1, 0.2 plus 0.2, 0.4 is the tolerance. But since the location of the second is with respect to the first, and for the second one relative to the first, 0.4 is the tolerance, relative to this common reference, tolerance will be 0.8. And for the third, 0.4 plus 0.4 plus 0.4, 1.2 millimeters. Well, such a deviation, such a tolerance may be too much, okay, to find the hole in alignment with the solid extension of the other component at the mating stage in assembling the components. So, well, if the such a tolerance going to be too much, if not a good thing to have tolerance accumulations, then don't use chain dimensioning. Advantage of chain dimensioning is obvious. Using only one row in this example can show 3 dimensions. But the disadvantage is important. The tolerances are additive, accumulated, so while the tolerance for one of the feature may be too much. Yes, for functional entities use not chain dimensioning but datum dimensioning. In datum dimensioning, a datum means reference, is selected, and with respect to the selected reference the dimensions are shown. Location dimensions are shown. Well, relative to this tolerance 0.4, relative to this for the second 0.4, relative to the third 0.4. In datum dimensioning there will be no say accumulations. Okay, deviations are not accumulated. It is a big advantage, but the disadvantage, well, say you see datum dimensioning uses not one row, but in this example for 3 holes, 1, 2, 3 different dimensioning rows. Datum dimensioning requires greater space to have on the drawing paper. Okay. The last few slides of the first presentation, it is about mainly the format of dimensioning format and also valuable definitions: tolerance, functional feature, functional dimension, non-functional dimension, non-functional feature. Okay, and the format to show to use in writing or in showing the functional dimensions and non-functional: old format, new format. Okay. Well, complementary things, you know, dimensioning rule. It says that extend the size of the feature to the vicinity of the projection using extension lines, and using one more line, it is called dimension line, show the dimension, write the dimension. It is in general true. But if the dimension is diameter or radius, then yes, it is the convention, it is under common agreement. Well, we omit the extension lines, we show the dimension line only. Not horizontally, not vertically positioning, tilting it. Okay, this is more common. Showing the diameters, use radially oriented dimensioning line. Okay, if the projection is very crowded with some other things, then extend the dimension line to the outside, not by using extension lines. Using the dimensioning line, have such extensions, then well, the arrowhead's going to be inwardly directed, and write the diameter along the extended part. Well, it is good practice to use preceding diameter symbol. Okay. If in the example you see it is object is a piece of cylinder, solid cylinder. So, well, since the meaning of diameter symbol is obvious that it is to say diameter, well, for such an object actually one view, which view? It should be lateral side view, is sufficient. No need to show the top view if it is the case that object is a solid piece of cylinder. Lateral side view, Normally, if there will be one view, okay, on the page, drawing sheet, to explain the shape and providing the size of the objects, then it should be front view, okay, it is under common agreement. So, well, here, selecting the lateral side of a cylinder as it is front side, only using it as lateral side view can inform the reader on everything. Well, looking at such a one, and thanks to the highlighting, it is done by showing the longitudinal axis. You learn this format requirement already, talking about studying on alphabet of the language. Okay, well, there is a rectangle, but over the rectangle we have longitudinal axis. This means it is the view of a cylinder. If there are two diameter values on the technical drawing and the surface limit lines are not parallel to each other, here these are not parallel, this means it is a cone, piece of cone, truncated cone. But if there is no axis on the technical drawing, this means it is the projection of rectangular prism, or if it is something like that, this means it is the projection of a trapezoidal prism. Okay, truncated pyramid. But here, yes, longitudinal axis is shining on the drawing, and diameter symbol is furtherly highlighting that it is the view of a cylinder. Since there is only one diameter value shown over here, or it might be indicated there, no doubt it is a cylinder. Diameter symbol and the longitudinal axis are sufficient to highlight that it is the image of a piece of cylinder. So no need to draw it as other side image. Yes. In accordance with ISO, we use, already talking about such things, diameter symbol, but in accordance with American definition, British Standardization Association, writing the diameter of a solid extension, we write the diameter value, no doubt it is going to be in inch, and this word. If the space is large enough, then write the word completely, say diameter. Diameter. Okay. If the space is limited, then can abbreviate it. How? DIA dot. Okay. There is one more symbol. ISO defines that symbol. It is just a square to its appearance. If it precedes a dimension, then it is to say that cross-section is a square. So in this example, you see this is the front view, let's say. This is the top view of what? Of a square prism. On the top view, we have width 25, depth 25. It is a square. Instead of showing such a view to highlight that it's a square prism, just use the lateral side view, draw the lateral side view, this view only, and showing the size of the prism, use square symbol. Yes, only by drawing or using the lateral side view, it should be by definition front side view of a square prism, can inform the reader on the necessary things, thanks to the special meaning of square symbol. Okay, this symbol. In accordance with ANSI or British Association, we do not use square symbol. We write the word to say square prism. Here the unit of measurement, no doubt, is inch. If the space is very narrow, limited, and so impossible to write the word completely, then abbreviated, say that SQ dot. If the dimension is not the diameter of a cylindrical piece or feature, but that of a sphere, then it is to be highlighted. You see, it looks like the profile view of a cylinder, but it is not. It is the image of a sphere. So write this word precedingly, sphere. Okay. Diameter symbol is optional. It is a good practice. Write sphere diameter 30. Okay. If it is a semisphere or spherical surface, then write the radius. Okay. Well, good practice to write letter R precedingly, and also this word is a must to write. To highlight that it is not a cylindrical surface but spherical surface. Here R is not optional. Okay. If it is a piece of spherical surface, not semi-spherical, not full sphere, but a spherical surface, then R is not optional, it must be written. And this is the radius. British notation, in accordance with ANSI, while writing the radius, we write the number first and then letter R. You know this. Hole specifications, already talk about it. Quickly review, talking about the hole creation facility of inventor. Remember, it was the CAD application, the second CAD application of the semester. After creating the model of a composite right prism in AutoCAD, then said that okay, create a similar one in Inventor. At that time, as one of the advantages of using Inventor, I said that hole creation tool is valid. Okay, in Inventor there is such a facility. Using hole creation facility can create the models of customized holes and also standard holes. Well, you can find the lecture note or video record and make a review on such things. But here, well, under title dimensioning, quickly make a review on the hole annotations. Well, if on the view, well, there is a leader line, such a line is called leader line. It has a horizontal shoulder and inclined arrow. Okay, the arrowhead is to touch to the projection of the entity, for which there is a technical note. It is in general called annotation. If the entity indicated by leader line is a simple hole means a truly extending hole, then we write the diameter only. Okay, the length of the hole is equal to, because is equal to the size of the composite feature in which there is such a hole. Whatever the size of this prism is, then length of the hole, since it is truly extending from one side to the other side, is the same. So write the diameter only. British annotation, American annotation is different. Write the diameter and then say drill. Okay? If the diameter is the size of a cylindrical extension or another extension, conical for instance, well, write the diameter value and then the word diameter in British format. Okay? But if it is not a solid extension, the diameter is the diameter of not a solid extension but diameter of a hole, then in ANSI format this word is written drill. If the hole is a blind hole, okay, well, write the diameter of the drill first, and then using this symbol, it is the depth symbol, okay, depth symbol, we write the depth of the hole. Repeat again, this conical end of the hole is sized naturally by the tip of the drill cutter. So saying the length of the hole or depth of the hole, we mean the depth of the cylindrical part only. In this example, it is 15. Okay, this is ISO representation, SI representation. British representation, write the drill first, in inch of course. Here it is in millimeter, but there it is in inch. After writing this word, then put a comma and write the depth value. Again, it is in inch, and put this word. Yes, well, at the entrance of the hose, well, to be able to hide something, the head of a bolt, for instance, we create a greater sized cylindrical space. It is called contour bore. If the head to height of the bolt or machine screw is conical, then using this cutting tool, the entrance is shaped as a conical space. Such a hole is called, it has a conical entrance, is called countersink hole. If the hole at the entrance of the hole there is a cylindrical, larger cylindrical feature, empty space, it is called contour bore hole. Okay. In accordance with ISO, this is ISO representation for a contour bore hole. Yes, this is in the example the edge view of a contour bore hole. On the view where see the edge of the surface of the cylinders of the hole, we indicate it with a leader line and then write the drill diameter first using the diameter symbol, and this is like capital U is the contour bore symbol to say there is a contour bore at the entrance of the hole. Following number is the diameter of the contour bore. Okay? And the depth symbol, yes, it is like capital T with an arrowhead. Write the depth of the hole. Here it is truly extending contour bore hole one side to the other side. No need to write the depth. But if the contour bore hole were something like this, well, draw it as sectional lateral side view. This one, contour bore. This is just the drill with conical end. It is not extending to the other side, and these are the cross-hatching lines. Sectional view. So half of the part, the hole is as if visible. These are the hatching lines. Okay, longitudinal axis. Okay, here if it is blind, then the height of the hole, the height of the conical end is not included. This value is to be written. Well, the note, for instance, H say that in the example, the length of the hole, depth of the hole is equal to, let's say, 30. Okay? The height of this part in which we have such a hole, let's say, is 50. Okay? Then for this hole, the annotation, hole annotation is written like this. Okay? Diameter symbol. Diameter of the drill, let's say again, is the same 10. Okay? After the drill diameter, write the, say, show the depth symbol, and then write the depth of the hole. 30 in this example. And then, comma, contour bore symbol to say that hole has a contour bore at its entrance. Diameter symbol, and write the diameter of the contour bore. Say that it is the same 18. Okay, and then depth symbol, one more time depth symbol. This is to write the depth of the contour bore. Okay, this size. Depth of the contour bore in the example is 5. Okay, the annotation will be in this form if the contour bore hole were a blind contour bore hole. British annotation is in this form. Drill diameter drill. contour bore diameter C bore means contour bore, and 5 deep. These words are used in American format. If the contour bore, height of contour bore or length of contour bore is in the order of 3 or less millimeters, then such a hole is called not contour bore but spot faced hole. Okay. In ISO annotation there is no difference, but American annotation, instead of saying contour bore, writing this word, we write S face, means spot face. If the hole is a countersink hole, yes, means at the entrance there is a conical cavity, then annotation is written like this. Capital V is the countersink symbol, and the following number together with the diameter symbol in ISO format. This is in ISO format. Okay. This diameter is the maximum diameter of the conical part. It is at the entrance surface, starting surface. In this example, this size is 18. And 70 is the cone angle, sink angle, the angle of the conical entrance. In this example, 70 degrees. British annotation, ANSI format. Actually, I already talked about such annotations while opening a parenthesis at the time. Remember how many weeks ago? I'm not so sure, but sure that talk about such things while demonstrating the hole creation method, hole creation facility of inventor. This is just to call your memory. NSI annotation for a countersink hole. Use this word, write C-sink or say countersink. If the space is sufficiently large, countersink, or abbreviated C apostrophe sink. Drill diameter, sink angle, and the maximum diameter of the countersink. It is just at the starting surface, the edge of the conical part of the hole. Okay. One more time, see if the size is radius of a rounding or fillet, then letter R is to precede, to say that radius, in accordance with ISO format. ISO format is this one. British format or American format, radius written first and then letter R is to follow. Okay. Showing the dimensions of cones or truncated cones. Well, although this format is applicable used, it is to say that slope of this inclined surface is 1 to 10 in this example. This means in the horizontal direction, okay, if the distance between any 2 points selected along the incline is 10, then in the vertical direction distance between 2 selected points is 1. It is just tangent definition, tangent alpha. And show the length of conical feature and one of the diameters. But this is more recommended, especially if your technician is not so good on understanding trigonometric expressions. Show the cone angle, show one of the diameters, maximum or minimum, and the length of the cone. Yes. You know what is chamfer? Along a sharp edge, cutting the material and creating a flat inclined surface. Okay, if it is the edge of a right prism edge formed by two flat surfaces, then cutting the edge, we have a flat inclined surface along the edge. It is called chamfer. Or if it is the edge of a cylinder or the edge of a cone, well, of course, chamfer will be a conical surface. To be able to prevent possible hand cuttings, it is one of the techniques. Just cutting the material along the edge, increase the sharpness angle, so decrease the hand cutting risk. If there is a chamfer, then showing the size of chamfer, you may use this format. Chamfer distance here in this example, it is measured over the cylindrical surface, and the chamfer angle, or this is more understandable, distance from here to there 4, and the inclination of the conical surface, inclination of the inclined surface is 40 degrees relative to this flat surface. Okay, and this is the last slide in my presentation. It is about patterns, the dimensions, okay, dimensioning format to provide the size of a pattern which consists of, say, eidetic circles. In this example, say that holes, if the holes have been equally distributed, it is a polar array. You know, what does it mean, array or pattern? Well, show the which axis? Radial axis and circumferential axis. Already talked about such things, remember. How about size? As the necessary dimensions, show the diameter of the circumferential axis and, well, indicate one of the members of the family of the array with a leader line, and then write the number of elements, number of members of the family. In this example, there are 8 holes, so write 8, cross, write the diameter of the indicated one, but it is to say that it is not for the indicated, but for all the others as well. Diameter is 10. And EQSP to say that the entities are to equally distributed. British format, well, after writing the whole diameter and writing this word, say drill, it is to say hole, put a comma and then write the number of members in the family in the pattern, in the example 8 holes, and then write this word holes. It is to say that for 8 holes, the size is the same. If the distributed ones are not equally distributed, then of course need to show their location dimensions, and if the diameter is not the same, then, well, indicate the groups different using different dimensioning annotations. Okay, finish this presentation. And then, dear students, after finishing this record, well, next video record, I'm going to talk about the second part of the chapter. It is about size tolerances. How the upper lower limits can be determined. How about the types of fittings? Talk about such things in detail. Yes, I have the necessary slides to project. Okay, next meeting you can see my delivery and also the projected slides. Okay, now ending this video record, my dear students.